Hey, look! I found my old slingshot. I'm trying to make a nicer one.
Why don't you try and make something cooler and more powerful using SOLIDWORKS? Let's do old school.
Let's do this together. What do you think?
Sure, let's make something using 3D Creator.
Awesome!
Mom is here.
Milk, eggs, bread,
Okay.
cheese.
Yeah.
Let's try it out.
Hey guys, we had a lot of fun trying to make this, and we learned some fun facts.
Yeah, so the main structure is made of 1/2-inch diameter aluminum rods, and the body assembly is made of 3D printed carbon fiber parts, and all the hardware is 1032 threaded, so we can just use one screwdriver for the whole thing so it doesn't turn into a nightmare. And The trigger is a simple spring-loaded jaw mechanism, so it won't open until I pull the trigger, so you would put the pellet or whatever you're shooting here. And the scope is a 4x fixed power scope, and the handle is a camera grip, which you can fasten any camera stand to the top or the bottom. The head is 3D printed with carbon and Kevlar fibers, and we put these wine corks here to hold the bands.
Now, one of the things we found with the head was actually it's a pretty important piece, because when this rubber band gets stretched, we don't want these to snap and hit the person on the face. So what we decided was to spend a little bit more time on the head, and we took it on inside SOLIDWORKS simulation and run some simulation to see at what load would it approximately break. Now, since this is a carbon fiber composite, we tried some basic classic lamination theory to get the stiffness constants. The other thing we did with this head, and this was kind of more for fun, is we took it into design guidance in xDesign, and we tried to do two things. One is, given a blob, and given that it's going to be fixed here and loads acting this way, give us the best shape. And xDesign and design guidance actually did that for us. And then the second thing we did with design guidance was we took the present design and said, given these loads, how can you make it lighter? And we found that, again, design guidance did a really good job. And then comes to the ammos.
Yeah, so we tried a variety of ammos with this, and so we used gummy bears, peanut M&Ms, and half-inch steel balls. So the gummy bears were terrible.
Yeah. We found that gummy bears were best suited eating them up rather than trying to do any target practice. And the reason that there is when you shoot the gummy bear, these things open up, and obviously in flight the inertia tensor changes and adds extra wobble, so accuracy basically goes to hell.
So the peanut M&Ms were actually surprisingly really good for this. They exploded.
Right.
Yeah.
And then the 0.5 inch diameter steel balls, actually those were the best. Clearly the inertia tensor is identity, so without any guidance or any barrel, that flies the best. We found that it was flying about 90 meters per second, which is about 200 miles per hour, and it weighs about 8 grams, so it has a kinetic energy of about 32 joules, and clearly it's capable of doing some serious damage.
Yeah. We're going to show you some examples of the peanut M&M and half-inch steel balls.